Okay, here's something interesting. We're looking at this analysis for Atlanta United versus Nashville SC, the game on May 3rd.
Right.
And some really smart models in this report point towards Nashville winning away, but then others using, basically the same kind of data, they strongly suggest Atlanta's going to take it at home.
It's fascinating, isn't it, how one single game, this MLS match at Mercedes-Benz Stadium, can generate such, well, different forecasts, even when you're using these powerful analytical tools.
Exactly. So welcome, everyone, to this deep dive. We've got our hands on a SmartBet AI-powered match analysis report. And this isn't just like a gut feeling.
Oh, no, definitely not.
It's a system using techniques borrowed from Premier League modeling, things like Poisson regression, which, don't worry, we'll break down ELO ratings, and even machine learning stuff like random forest, XGBoost, a neural network, too.
Yeah, if you step back a bit, what we're really talking about here is sports analytics, right? Trying to use data, lots of it, to generate probabilities, to put some numbers on likely outcomes instead of just guessing.
And that's the idea here for you listening. This is kind of your shortcut to understanding how all this works without getting totally lost in the technical weeds. We want to pull out the key insights, those sort of aha moments you get when you see how different methods attack the same problem.
And maybe see why predicting soccer is just so darn difficult, even with all this tech.
Absolutely. So our mission, if you will, for this deep dive is to unpack these predictions, look at the methods behind them, and really help you get a feel for the different viewpoints and, well, the uncertainty involved.
Sounds like a plan. Where should we start? The match basics.
Yeah, let's set the scene. Atlanta United versus Nashville SC, May 3rd, 2025. It's at Mercedes-Benz Stadium.
Got it.
The report even throws in the weather. Mostly cloudy, a bit of wind from the northwest, maybe a 25% chance of rain, around 75 degrees Fahrenheit.
Okay, probably not a huge factor in the models themselves unless it's extreme, but yeah, good context to have. That kind of weather usually means decent playing conditions.
Right. Now, speaking of context, the report dives straight into injuries, which is always a big deal.
Always. So for Atlanta United, let's see, Stan Gregerson is out, quadriceps. Tristan Muyumba, adductor, and Derek Williams has a hamstring issue, all marked as OUT.
That's quite a few key players, especially defensively, it feels like.
It is, and Nashville's not escaping injury-free either. Tyler Boyd's out with a knee problem. Maximus Eck, also knee. Julian Gaines, thigh. And this one's significant. Walker Zimmerman is out, head injury.
Oof, Zimmerman's a big loss for Nashville's backline. Huge presence.
Absolutely. Now, the report doesn't tell us exactly how much weight the models give each specific injury,
Right.
But it does say injuries are included as a contextual team feature, and they're factored into that Poisson regression thing we mentioned. So the models are aware these guys are missing.
Okay, so both teams are definitely feeling the impact of injuries. Let's move on to something called ELO ratings. Sounds a bit like chess rankings.
Huh. Yeah, it's the same basic principle, actually. Adapted for team sports. Think of it as a dynamic measure of team strength.
Dynamic how?
Well, unlike just looking at the league table, which is static at a point in time, ELO ratings change after every single match. They go up if you win, down if you lose.
Okay.
And how much they change depends on the result, but also on who you played. Beating a strong team gives you a bigger ELO boost than beating a weaker one. Losing to a weak team hurts your rating more. So it reflects current form and strength relative to opponents.
Gotcha. So it's constantly adjusting. What are the ELO ratings telling us about Atlanta and Nashville right now?
According to this report, Atlanta United's ELO is 1,497.73. Nashville SC is just a fraction behind at 1,484.88.
Wow, that is really close. Barely any difference.
Exactly. It suggests these teams are, according to this metric anyway, very evenly matched. And importantly, the report notes these ratings are adjusted for injuries.
Okay.
So the system has tried to factor in those absences we just talked about when calculating these current strength scores.
Interesting. So a tiny edge to Atlanta on ELO, but basically a toss-up. Now, you mentioned Poisson regression earlier. Sounds statistical.
It is, yeah. But the core idea is pretty straightforward for sports. It's a statistical method used to predict count data, like how many times something happens. Exactly. In this case, it's used to predict the number of goals each team is likely to score in the match.
And how does it do that? Does it just look at past goals?
It looked at a whole range of things. Recent form, definitely. Team strength, maybe using those ELO ratings. Home advantage is a big one, usually.
Right.
It can also factor in things like betting market odds, those injury lists we discussed. Basically, any relevant factor you can quantify.
Okay, so it's crunching a lot of numbers to estimate the score. What does it predict for this game then? The expected goal.
The model predicts Atlanta United scoring about 1.24 goals on average, and Nashville SC scoring about 1.21 goals.
Again, incredibly close. A tiny, tiny edge for Atlanta in expected goals.
Precisely. Like the ELO ratings, this points towards a very tight contest, at least in terms of expected goal output.
Okay, but wait. The report then mentions bootstrap Poisson regression and confidence intervals. Uh-oh, getting deeper now.
Just a little. But it's important for understanding uncertainty. Think of bootstrapping like this. The model takes its initial prediction, like that 1.24 goals for Atlanta, and then it simulates the match thousands of times based on that rate, but allowing for randomness. It's like playing the game out on a computer 10,000 times to see the range of scores that pop up.
Okay, so it explores the possibilities.
Exactly. And the 95% confidence interval tells you the range where the actual number of goals is likely to fall 95% of the time based on the simulation. It gives you a sense of the potential variation.
Right, because 1.24 goals isn't actually possible in a real game, so what's the range?
Well, that's what's really revealing. For Atlanta at home, the predicted mean is 1.22 goals, but the 95% confidence interval is, get this, 0.0 goals to 4.0 goals.
0 to 4, that's a huge range.
It is. And for Nashville away, predicted mean 1.24 goals. The confidence interval is exactly the same, 0.00 to 4.00 goals.
Wow. So while the average prediction is super close, the models acknowledge that anything from a 0-0 snooze fest to, well, a 4-4 thriller is statistically plausible, if unlikely at the extremes.
That's the perfect takeaway. It really underlines the inherent unpredictability. You can have an average expectation, but soccer matches have wide variance.
Definitely paints a picture. Does the report mention anything else about how that Poisson model works, like what factors were important?
Yeah, it briefly touches on the model summaries. Without getting lost in the stats weeds, it mentions things like, for the home goals model, the betting market probabilities and the home ELO rating seem significant.
Okay, so what the betting world thinks and their current strength. Makes sense.
And for the away goals model, things like a baseline expectation, statisticians call it the intercept, plus the away team's market probability and ELO rating were important.
So similar factors for both, adjusted for home away. It's like seeing a little bit under the hood, isn't it?
Exactly. It shows the model is weighing multiple angles. Now, we also have the machine learning classifiers.
Right. Random forest, XGBoost, and the MLP Neural Network. These sound way more futuristic.
They are pretty sophisticated tools. Their goal here is slightly different from Poisson. They're trying to predict the overall match outcome directly. Home win, draw, or away win. A classification task.
So not predicting the score, just who wins or if it's a draw.
Correct. Each uses a different approach to learn patterns from past data and make that classification.
Can you give us the quick version of how they differ, like random forest?
Okay, random forest. Imagine building hundreds, even thousands of simple decision trees, like flowcharts. Each tree gets a random sample of the data and makes a prediction. The final outcome is basically a vote, whatever the majority of trees say, that's the prediction. It's robust because it averages out errors.
Okay, strength in numbers. What about XGBoost? That sounds intense.
XGBoost stands for extreme gradient boosting. Also uses trees, but it builds them one after another. Each new tree focuses specifically on correcting the mistakes the previous trees made. It's like a highly efficient learning process, often very powerful.
So it learns from its mistakes sequentially.
Cool.
And the neural network, MLP.
Multi-layer perceptron. Think of it like a simplified model of the brain. It has layers of interconnected neurons that process information. It can learn really complex, nonlinear patterns in the data that other models might miss.
Okay, 3 different high-tech approaches. So the million-dollar question, what do they predict for Atlanta versus Nashville?
All right, here's where it gets really interesting again. The random forest model predicts an away win for Nashville.
Away win. Okay, first marker down for Nashville. What about XGBoost, the error-correcting one?
XGBoost disagrees. It predicts a home win for Atlanta.
A home win. Okay, so we have a split already. One for Nashville, one for Atlanta. What does the brain-like neural network say?
The MLP neural network also predicts a home win for Atlanta.
Right, so that's 2 models, XGBoost, and the neural network pointing to an Atlanta victory, and 1 random forest favoring Nashville. Fascinating split.
It really is. And the report gives accuracy scores, too, based on past performance. Random forest was around 0.58, XGBoost 0.57, MLP 0.52.
So accuracies in the high 50s, low 50s% range shows how tough prediction is, right? better than a coin flip. But
Exactly. Predicting a three-outcome result, win, draw, loss, consistently is very hard in soccer. These accuracies reflect that reality. They've been right about 52–58% of the time on past data.
okay, now there's another layer here. A stacked ensemble. What on earth is that, combining them?
That's precisely the idea. A stacked ensemble, or stacking, is a way to combine the predictions of those individual models, the random forest, XGBoost, MLP.
Is that just average to them?
Not quite. It uses another machine learning model, a meta model, whose job is to learn the best way to combine the predictions from the first set of models. It learns, for instance, maybe XGBoost is usually better when predicting home wins, or random forest is better for away games, and weights their input accordingly.
Wow, okay. A model managing other models. Very meta. So what does the stacked ensemble, the super predictor, say?
The stacked ensemble predicts an away win for Nashville.
Another vote for Nashville. So now we have random forest and the stacked ensemble predicting an away win, and XGBoost and the neural network predicting a home win. It's tied.
It is. And interestingly, the reported accuracy for the stacked ensemble is 0.63, a bit higher than any of the individual models.
Which suggests that combining them did maybe improve the overall predictive power slightly, at least historically.
Potentially, yes.
Yeah.
That's the goal of stacking.
Man, this is complex. Okay, one more angle. Monte Carlo simulation. Sounds like gambling in Vegas.
Huh. It borrows the name because it involves randomness and repetition, like casino games. But here, it's using those goal predictions from the Poisson regression. The 1.24 for Atlanta, 1.21 for Nashville.
The really close ones, yeah.
Right. It takes those average rates and simulates the match thousands of times, 10,000 times in this report. Each simulation generates a potential scoreline based on those probabilities.
So it's like playing the match 10,000 times and fast forward to see what happens most often.
That's a great way to put it. By running so many simulations, you get a distribution of the most likely scorelines and overall outcomes.
Okay, so after 10,000 virtual games, what scores came up most frequently?
The single most common scoreline was a 1-1 draw. That happened in 12.5% of the simulations.
A draw. Interesting. What else was common?
Next most likely was a 1-0 home win for Atlanta, 10.78%, followed very closely by a 0-1 away win for Nashville, 10.4%. And then a 0-0 draw was also quite frequent in 9.18%.
So the top four most likely scores are all really tight, low-scoring results, with two of them being draws.
Exactly. It strongly suggests, based on the Poisson inputs, that a close, low-scoring game is the most probable scenario according to this simulation method.
What about the overall win-draw loss probabilities from all 10,000 simulations? Did one outcome dominate?
Not really dominate, no. It was remarkably close again. A home win for Atlanta occurred in 37.04% of simulations. A draw happened 35.56% of the time. And an away win for Nashville occurred in 27.4%.
Wow. So home win and draw are almost identically likely, with away win a bit less likely, but still very much in play.
Precisely. The Monte Carlo, perhaps more than any other method here, emphasizes just how balanced this matchup looks on paper, statistically speaking.
Yeah.
A slight lean towards Atlanta or a draw, but Nashville is definitely not counted out.
Okay, let's try and wrap our heads around all this. We've got ELO ratings showing the teams are neck and neck.
Yep, adjusted for injuries.
Poisson regression predicting almost identical goal counts, but with huge confidence intervals showing high variability.
0 to 4 goals possible for either side.
Then the machine learning models are split. Two predict an Atlanta home win, XGBoost MLP, but two others predict a Nashville away win, random forest stacked ensemble.
Right, a complete contradiction there on the most likely outcome.
And finally, the Monte Carlo simulation highlights the 1-1 draw as the most likely single scoreline and shows the overall chances of a home win, draw, or away win are all really close, with maybe a slight edge to Atlanta or a draw.
That's a perfect summary. Different methods, different nuances, and sometimes different bottom-line predictions. It really drives home the uncertainty inherent in sports forecasting.
So for you listening, hopefully this journey through the different models gives you a much richer picture than just seeing a single prediction somewhere.
Yeah, you can see how analysts arrive at these things. ELO gives you team strength context. Poisson gives you goal expectations. ML gives you outcome classifications. Monte Carlo gives you probability distributions. Each adds a piece to the puzzle.
And you get that aha moment, realizing why it's not simple. Even with fancy AI and stats, predicting 90 minutes of soccer with all its variables, it's tough. The models reflect that uncertainty.
Which brings us to a final thought, maybe something for you to chew on. Given all these different results, the split ML predictions, the high chance of a draw in the simulation, the close ELO ratings, What single factor do you think will actually be the most decisive thing on match day?
Yeah, what tips the scales? Is it a specific player matchup? Is it who handles the pressure better? Maybe one team converts their chances slightly more efficiently?
Or which prediction method resonates most with you?
Mm-hmm.
Do you trust the ensemble, the simulation, one of the specific ML models? Why?
Yeah,
Makes you think about what you value in a prediction.
absolutely. And of course, we should always, keep in mind these are just forecasts.
Oh, definitely. Data models, probabilities, not crystal
The
balls.
actual game is played by humans on grass, and anything can happen. That's why we watch, right? So treat these insights as interesting perspectives, not guarantees.